All right, good morning, ladies and gentlemen. We are going to cover salt hydrolysis this morning. It won't take very long. We've got 3 slides to look at with some examples. And then I'm going to hand out to you the lab sheet that we're going to see tomorrow in lab. It involves quite a bit of prediction. And so the goal is that we can predict whether our salts are acids or bases and what that means, or if they're neutral. And then we're going to test them tomorrow and see how well our predictions were. So as we look at the first slide here, by definition, salt hydrolysis. Salt is referring to any ionic compound, which we mentioned yesterday with the neutralization. Right here, salts are ionic compounds. And then hydrolysis, hydro meaning water, lysis meaning split or splitting. So the idea is that we're taking the salt, we put it in water, and we're splitting it into its respective ions, and then we see how it interacts with water. So it says in the first bullet point, if a salt is added to water, a small amount of acid and base are produced. Now, the acid part, we call that the parent acid. And then the base part we call parent base. And the strength of the acid and base parents will determine the pH of the salt solution. So what we're going to see in a moment is if, our parent acid we can determine to be a strong acid and then the base is a weak base, then overall we have an acidic salt. If it's flipped around, we have a basic salt. If they're both strong, it's neutral. So the nitty-gritty of this, how do we find or predict the parent acid and the parent base? Well, I'm going to use pink for acid because we'll see tomorrow with the litmus paper that the red paper is for acidic stuff. The blue we typically associate with bases. But to find the parent acid here, it says we're going to replace the cation with H+. And it's not just one H+, but it's enough to balance the charges. So in the example, if we take sodium chloride as the salt, we are replacing the sodium with an H, or with a proton. Okay, so where we would have had Na plus with Cl minus, now instead of Na plus, we put in H plus. And so H plus and Cl minus together make HCl. Okay. To find the parent base, it says we're going to replace the anion with hydroxide. For example, if we have Na plus, again with Cl minus for sodium and chloride, the idea is that we're going to replace the Cl minus with hydroxide. And the goal is we need to replace it with enough hydroxides to balance the charge of the cation. Cation's a +1, hydroxide's -1, so they go together well. And what we see is NaOH. Now, a key step here, which are going to make some of you groan, is that this requires knowledge of proper formula writing. If you're not great with formulas from Chem 1, you're going to be able to get close, but it still might look atrocious. I'm just stating that from past experience. So we got to do our best to make the formulas look as right as possible. You can look at the formula, and based on the subscripts, you should be able to figure out what the charge of the anion or the cation is. And then if you're replacing with H plus or hydroxide, you should be able to figure out how many of each you need to balance that formula. And I'll show some examples to you in a moment. So for salt hydrolysis, like we just figured out, the parent acid for sodium chloride is HCl, and the parent base is sodium hydroxide. So how do we know whether the salt is acidic, basic, or neutral? Well, we need to identify whether our parent acids and bases are strong or weak. In this case, we have HCl and sodium hydroxide. Hydrochloric acid, is that a strong acid or a weak acid? What do we recall from yesterday? Strong, weak. Which one? Strong. Okay, so HCl is a strong acid. Sodium hydroxide, is it a strong or a weak base? Strong base. So notice if we have a strong acid and a strong base, they kind of cancel each other out, meaning the salt is neutral. Okay. If we had a weak acid with a strong base, then the base is kind of winning out, so we're a basic salt. If you're strong acid and weak base, then our salt is acidic. And if for some reason both the acid and the base are considered to be weak, it would depend on the size of the Ka and the Kb, which is the acid or base dissociation constant. It's an equilibrium constant of sorts. We're not going to worry about that. We would consider that to be an honors level. Okay, so let's do this. Let's I'm going to hand out to you the lab for tomorrow. And we're going to take a couple minutes and we're going to do a few examples together where we can predict what the salt should be. And I know it says honors 2 on here. It's the same lab that we're doing. Okay, so the goal for the lab tomorrow is that we're going to investigate what occurs to the pH of a solution when various salts are dissolved in water. We'll have the salt set out. Trying to remember if we have enough for every table or not. It might be that way. But it says obtain a pea-sized granule of each of the salts, add it to 10 milliliters of distilled water in a test tube. So you're going to get, it says 10 milliliters, but really if you have a large test tube, okay, then I suppose a small one. Usually instead of 10 milliliters, I just say 3 finger lengths or 3 fingers worth of distilled water in each test tube. And that's sufficient. It's about 10 milliliters in a large test tube. And you're going to dissolve the salt, if it does, in it by moving the stirring rod in it. And then you're going to have red litmus paper and blue litmus paper, and you're going to take the tip of the stirring rod and you're going to dip it in the solution and then touch the red paper with it and touch the blue paper with it. And we're going to look at the colors. So if the red changes to blue, then it suggests that we're basic. If the blue stays blue, so let me put it this way, if we have red goes to blue and blue stays blue, then we're basic. If red goes to red and blue stays blue, then we're neutral because it's saying it's acidic and basic. And then if red stays red and blue goes to red, then we are acidic. And you have to watch because the blue to red might turn up a little bit purplish, but it's still a significant enough color change we could classify it that way. So to do this, let's look at the first example. We have sodium carbonate. So to do the acid parent, we're going to put enough H pluses in to replace the cation. Now the cation is sodium. Sodium's a +1. So our acid parent will be H2CO3. And then for the base parent, we replace the anion with hydroxide. So we have sodium hydroxide, which would be this. Okay. Now, what do we expect this to be? Carbonic acid, is this a strong acid or a weak acid? Is it on your list of strong acids? No, therefore it's a weak acid. And then sodium hydroxide, strong or weak base? Strong base. So since one is strong and one is weak, we're going to follow the strong, which means we would expect this one to be basic. Yeah. No, so we put enough hydroxides to match the charge of the sodium. Sodium's a +1. Okay. If we look at the next one, for the acid parent, we want to put enough H's in to balance the charge. Now, sulfate is a -2 charge. Did I give you guys a printout of the periodic table this semester? Like your own copy of the periodic table? Thought I did for the first unit. So on the back side is the list of polyatomic ions. You can match up sulfate SO4 on the back side and see it has a -2 charge. So how many H's do we need to balance the -2 charge? We need 2 of them. So the acid parent is H2SO4. And then the base parent, if this copper is with 1 sulfate, that means copper here is a +2 to balance the -2 at the sulfate. So we need 2 hydroxides to balance it. Is sulfuric acid strong or weak? It is a strong acid. Copper 2 hydroxide, is it strong or weak? Try again. You should see that it's a weak base. So the acid is what's strong, so we would expect this one to be acidic. In fact, what's interesting is there's some places, I believe there are copper mines, that the the groundwater, the runoff from the mines in nearby rivers have actually turned the bodies of water an incredibly greenish teal color because of the copper sulfate that leaches in, that's in the solution. And in fact, it makes the water extremely acidic. That there's one story where it killed all the fish that were in there because fish have a certain ecosystem they live in with a certain pH. And sulfuric acid is such a strong pH, it's below 0, that it killed all the fishies. Okay, so your homework this evening is to go through the rest of this list and do your best to identify the acid parent and the base parent, and then identify or predict whether you think the salt's acidic, basic, or neutral. Take care.